All right, so another example where we can use net change is total consumption. Okay. So basically we can use an integral as a tool to calculate net change and total accumulation, right, of not only distance and velocity. We can use this for also growth, we can use it for decay, and we can use it for consumption. Basically, if you want to find the cumulative effect of a varying rate of change, you have to integrate it, right? And so basically what we're going to be doing here is you will be given a rate and you will need to find an amount or a quantity. Okay? All right, so take a look at the first one. From 1970 to 1980, the rate of potato consumption in a particular country was this. So this is the rate, okay? And it's given in millions of bushels per year, because that's what we talk about in AP Calculus, is just bushels of potatoes. Millions of bushels of potatoes. T is yours since the beginning of 1970. So this is, T equals 0. How many bushels were consumed from the beginning of 1972 to the end of 1973? So from the beginning of 72 to the end of 73, that's a total of 2 years, right? Okay, so if T is 0 at 1970, at the beginning of 1972, T is equal to 2. And the end of 1973, T is equal to 4. So basically, this is like December 31st, 11:59 p.m., right, of that year. So it's like the full 2 years. Okay. So what do we need to find here? We need to find the total consumption, right? So the total consumption is, remember, we have a rate. We need to find the amount. That's an integral. From 2 to 4, 2.2 plus 1.1 to the power of t dt. And that we're going to put into our calculators. 2.2 plus 1.1. So it's basically that, here, this is the one, okay?
So we can use calculator for every single one?
Yeah, for these you can use your calculator. So you would go into this menu next to the 9, right, that toolbox, and the integral symbol is there. And then to go between one field and the other, just press tab, 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 okay? So you're going to plug that in, and the calculator gives me 7.066. So there you go. In the context of the problem, though, that's not like 7 potatoes that was consumed over the 2 years, right? That's 7.066. How much? Millions of bushels. Okay? So this is 7.066 millions of bushels.
I did not get that.
Did you put in the integral exactly as we have it? 2.2 plus 1.1 to the power of x?
No.
Okay. So now, what were we given here, right? We were given a rate. Let's talk about units for a minute. We were given a rate in terms of millions of bushels per year. So the unit here is millions of bushels per year. And then this and this and this are in years, right? Remember all those three come together, they're a unit. Mm-hmm. These are years. So bushel per year times year, that does give you bushels. Okay? Right? Okay. So again, what did we do in this problem? We were given a rate and we needed to find the amount consumed. Okay, next. This is a given, this is a graph of the velocity of a particle moving on the x-axis. The particle starts at x equals 2 when t is 0. So, this is the initial value. Find where the particle is at the end of the trip. Where the particle is, that's the position, right? At the end of the trip, at 10 seconds, because this took 10 seconds. So S of 10 is what we need to find. Since this is final position, we learned last time that final position, I don't need to write all this out. Final position, which is S of 10, is equal to initial position plus displacement every single time. Okay?
Quick question also, not just for this problem that we're doing, or the last two examples that we've been doing, but for the first 5 examples of this 8-1 unit, can we also use the calculator for those?
Yeah.
Right? Because it seems like we've
Yeah.
never even brought it out on the sheet.
Yep.
I guess it is.
So S of 0 is 2 plus, okay, how are we going to find that integral? What are we going to do? Huh? What are you given? Where's your velocity? The graph is the velocity, so how am I going to find that integral?
Oh, you're going to take the area.
Area. Okay? We're going to find the area.
This is the velocity graph? Okay.
Okay? So the integral is the area. This is the height over 2 base 1 plus base 2. This is half times base times height. We're going to subtract, right? So it's going to be 9 minus 4. Okay? So the final position, it's x of 10, not s of 10 actually. X of 10 is 7. So the position along the x-axis at 10. B is the total distance traveled, so that's from 0 to 10, the absolute value. So what does that give me? In this case now, it's going to be positive 9 plus 4 equal to 13, the absolute values of them. Okay? A pump connected to a generator operates at a varying rate depending on how much power is being drawn from the generator to operate other machinery, right? So, the rate in gallons per minute at which the pump operates is recorded at 10-minute intervals. And you have the data for 1 hour as shown in the table below. How many gallons were pumped during that hour? Okay? So again, what are we given? We are given a rate. You need an amount. Yes? Okay. So this time it says to use a trapezoidal rule to approximate, right? Because how would you find the amount if you're given a rate? You need to take an integral. Well, I don't have a function to take the integral of, but what's integral also the same as area? Well, given this, how do I find area? Trapezoidal rule. So do you see how they're all the same thing? Okay, yeah.
So would you do integral from 0 to 10 and then integral of, and then you would add 58 plus?
Right, so we don't even need to write an integral because we don't have a function or something to put it into. So, but we're just going to do the trapezoidal rule, right? Notice these are all 10-minute intervals and they're evenly spaced. So it's going to be height divided by 2 times 58 plus 2 times all of these, 65, 58, 55, 59, 60, and then 1 of 63.
Is it trapezoidal rule?
Yep. Okay. And it will come out to 3,575. Okay, let's talk about units for a minute. This is the time, right? In minutes. What's this? Gallons per minute. It should be gallons, and it is gallons, so gallons. Okay.
Do we need to write that, or can we kind of just,
The units?
like, do we need to write the
No.
minutes times gallons on
You don't have to write minutes times this, but you have to write
Yeah.
the final
yeah,
unit
yeah.
here. Okay, now, so that's section 1, but let's recap now. Let's tie things together. In this case, again, you were given rate, you needed the amount. You were given rate, you needed the amount of distance traveled. You were given rate, you needed the amount of potatoes consumed. But the way in which we were given all of these things was different. So here, okay, rate given as a table, okay, and we had to use either trapezoidal or Riemann to do it, right, to do the integral, yeah? Here, rate is given as a graph. And we needed to use area to find the integral. So in both cases, you're finding integral. But one is by trapezoidal, one is by area. Here, you're given rate as a function. And you did a straight integral with antiderivatives to find the amount. Okay? So I want you to recognize that in all three situations, you were given rate, you needed to find amount, which means you had to integrate. But the integral, like the form that we integrated, was different. One was by anti-differentiation, one was by area, one was by trapezoidal rule. Okay? Okay.